Hey there! Today, we're going to break down one of the most useful shortcuts in all of algebra, the power rule for exponents. By the end of this short explainer, you'll be able to turn a really complicated-looking problem into something super simple. Let's jump in.
Okay, take a look at this. At first glance, it might seem a little intimidating, right? You've got negatives, coefficients, a couple of variables, and exponents all over the place. But I promise by the time we're done here, you'll know exactly how to tackle this, no sweat.
So first things first, what exactly is this power rule we're talking about? Let's get a really clear definition so we know what we're working with.
Here it is in a nutshell. The power rule says that when you raise a power to another power, like you see here with x to the a to the b, all you have to do is multiply those exponents together. That's it. This is the big idea we're going to be using today.
But, just memorizing a rule is only half the story. To really get it, to really make it stick, you got to understand why it works. This is where you get that aha moment. To figure out the why, let's use a nice, simple example. X squared, raised to the third power. We're going to pull this apart and see what's actually going on under the hood.
Okay, so check this out. That little 3 on the outside just means we need to multiply the thing in the parentheses, x squared, by itself 3 times. And what is x squared? It's just x times x. So if we write the whole thing out, we literally have 6 x's all multiplied together. And that's just x to the 6th power.
So you see, the power rule is just a fantastic shortcut for that whole process. Instead of writing all that stuff out, we can just look at our original exponents, the 2 and the 3, multiply them, and bam, we get 6. Both roads lead to the same answer, x to the 6th, but our new shortcut is way, way faster.
All right, now that we know what the rule is and why it works, let's put it into action. We'll walk through a couple of examples together to really build up that confidence. Let's start with a really quick one. We've got x squared raised to the 8th power. We just use our rule, multiply the exponents. 2 times 8 is 16. So our answer is x to the 16th. See? Super direct.
Okay, ready for one with a few more moving parts. This one has a coefficient, that's the number in front, and 2 different variables. The trick here is simple. That exponent on the outside applies to every single piece on the inside. Let's do it step by step.
First up, let's take care of that coefficient, the 2. The exponent on the outside applies to it just like everything else. So we have 2 to the 2nd power, which is just 2 times 2, and that's 4.
Next, let's look at our a variable. We have a cubed being raised to the 2nd power. Time for our rule. We multiply the exponents. 3 times 2 gives us 6, so that part becomes a to the 6th power.
And finally, we've got the b variable. It's b to the 4th raised to the 2nd power. Let's multiply those exponents. 4 times 2 is 8. So this piece simplifies to b to the 8th.
All right, for the grand finale, we just put all our simplified pieces back together. We have our 4 from the coefficient, our a to the 6th, and our b to the 8th. The final answer is 4, a to the 6th, b to the 8th. See? Not nearly as bad as it looked when you take it one piece at a time.
Okay, this next part is really important. There's a super common mix-up that happens with exponent rules, and I want to make sure we get it cleared up right now so you never fall into this trap.
So on the screen here, you can see a few different exponent rules. We're going to zoom in on the 2 that are easiest to confuse, the product rule and our new friend, the power rule. Knowing when to use which is absolutely key.
So here's the dead giveaway. On the left, with the product rule, you're multiplying 2 separate things with the same base. In that case, you add the exponents. But on the right, with the power rule, you have one base with the power raised to another power. Those parentheses are your biggest clue. That's when you multiply. Just remember, separate terms you add, power of a power you multiply.
Okay, we've covered what the rule is, why it works, and even a common mistake to avoid. I think you're ready. Now it's your turn to take the controls.
Here's a problem for you. In a moment, go ahead and pause this explainer, grab some paper, and see if you can simplify this expression. Give it a shot, and then press play when you're ready.
All right, welcome back. Let's check your work. So we need to distribute that outer exponent of 2 to both variables. For the m term, we use the power rule. 3 times 2 is 6, giving us m to the 6th. For the n term, we do the same thing. 7 times 2 is 14, giving us n to the 14th. Put them together, and our final answer is m 6th and 14th. How did you do?
And that right there is the magic of this rule. You have learned how to take a problem that looks kind of complicated and turn it into a couple of simple multiplications. That is an awesome tool to have in your math toolbox.
So you've totally nailed how to handle powers of powers. But what happens when one of those exponents is a negative number? Now that is where things start to get really interesting, and it's the perfect next step in your algebra adventure.